Right, great. Thank you for that nice introduction, Dhammika. I know you are in the move. Sorry, there was a small technical glitch as I start. So without further delay, let me start the session. Thank you for Amila and the committee for inviting me for this session. So today we are going to tap into the area of Six Sigma. Let me share my screen. I hope I'm audible to you all.
Yes, Targa, loud and clear.
Great. Right. My screen is visible to you all?
Yes.
Great. I will give you a glimpse about how the evolution of Six Sigma happened, how these very commonly known, very popular name came into being, and then I'll give you a rough idea about the Six Sigma as a concept, how the deployment happens, and what is the concept behind Six Sigma. And there'll be some time for discussion, and maybe you can share your idea about the session in the next small session. So this is our session, and don't hesitate to disturb me and ask any questions at any point of the during the session. I'm quite okay with that. All right, let's start with that our session. So would you be surprised to know all of this started with a jinn? So beginning of 1800, 1793, the first industrial revolution happened. This gin, the word came into being. Of course, it's not a bottle of gin, but it's a machine. This machine is actually used to extract cotton from the seeds. During the time, this cotton was becoming industry was becoming very unpopular because it's not commercially viable due to hiking labor rates. This person called Eli Whitney, he identified this problem and invented this machine. But he, during this time, I mean, he couldn't enjoy any IP rights for this machine. Everybody started copying the machine and making use of it. Am I okay? Amila, can you see the screen?
Yes, yes, all okay.
Great. So please don't hesitate to, I mean, interrupt me during the session and ask questions. All right. So this machine didn't have any IP rights. Everybody copied and made this industry profitable. So US, I mean, America was very happy about this machine. So as a result, Eli Whitney, he went to become one of the postal stamps of America. And thereafter, he won a contract from US government to produce muskets. He had to produce 10,000 muskets. It's also very funny because these are not the muskets that we day to day talk about. These are a type of shotguns. So during this shotgun manufacturing, interestingly, he used something called interchangeable parts in producing these machines, these shotguns. This was the first instant in history. The interchangeable parts were used. It is actually something like the production line moves on and the value additions happens from the sides. The parts change, so the product comes out of the production line is different. Like one production line, like Toyota production line, produce high, say a Prius and then a Premio and then a Corolla. something like that. So that this really happened at first in this point. So so many inventions related to quality and the productivity happened, but this go and no go gauges became something because this was the starting of specification limits. So when it comes to customer requirement, customer has a tolerance. So to defining customer tolerance, the specification limits came into being with this go and no go gauge. And we all know the Henry Ford's moving production line, 1913. You can see this moving production line moving on. There's an engine here. Using this engine, this production line was moving. And apart from this, many of the things, innovations relevant to Six Sigma started with Western Electric. Starting from the statistical quality control. Now, what you can see here is a control chart. This is an invention itself by Western Electric in Hawthorne. Some of you, if you are from manufacturing industries, I think you would have heard about Hawthorne effect when it comes to manufacturing. This Hawthorne effect itself came from Western Electric manufacturing site in Hawthorne. So many of the quality leaders relevant to initiation of Six Sigma, especially statistical quality control, came into being from Hawthorne factory. People like Edward Deming, Joseph Juran, Walter Schwartz. So all of these people worked for Western Electric. This was the Western Electric symbol during the time. Today, the organization is not existent. It has gone into several other organizations. Now today, AT&T, even Nokia, Alcatel-Lucent, some of these organizations are the parent organization of those are the Western Electric. So many things happened, but in 1950, the US government made it's mandatory for all its suppliers to maintain statistically based quality levels. So this is soon after the Second World War. Apart from these things happening in US, of course, Japan was trying to boost up their production, trying to become an industrialist. So some of the leaders or well-known people from US went to Japan on consultancy assignments to help Japanese industrialists. So people like Homer Serahon and even Edward Deming, so many people went, but I would like to highlight one special person, the Joseph Juran, because during this time, the high focus was on the defects. This amount of defects are there, so we have to reduce the defects. So that was the high focus when it comes to improving the productivity in a manufacturing place. But Joseph Juran came up with a theory called big Q and small q, where the small q referred to the defects, or the quality, the percentage of quality level, and the big Q referred to the big picture, everything apart from defects, but things relevant to defects, like the quality of supplies, quality of the labor, quality of or the talent of people, the environment conditions, the productivity of machines, all of the other things, the motivation of people. So all of these things he considered as a big Q. This is one of the turning points, because even today now we could be knowing the output indicator like the small q, the quality level. For instance, now if we today now when we drive a vehicle, we of course obviously know what is the speed of the vehicle. That is an output indicator. That is the result of something. But if we do not know how to decrease or increase the speed, there would be no point of knowing the speed. So similarly in here, knowing the small q is fine, but how to control the small q are in the hands of the big Q picture. So so many of these inventions happened in the industry, but after 20 years, in 1973, Japan was focusing on the defect elimination and reducing the cycle times to improve their productivity in manufacturing industry. But US was still the industrial leader. So if they were enjoying the lucrative market shares and maintaining that, enjoying that the volume. But this only went on until the fuel boom happened in mid 70s. When the fuel boom happened, the people started looking at, like, realizing their Japanese motor vehicles are more fuel efficient. Whoever the biggest consumer during the time was also US, so they had a Japanese vehicle. Some of the US consumers had Japanese vehicle as a second vehicle. But during this fuel boom, they started to realize that second vehicle, which is a Japanese, is more fuel efficient, and they started using that more frequently. And they again started to they also found out that's actually it's more reliable than the American vehicles. So this gave a lot of attention to Japanese products in US market, being the highest consumer in the world. But it didn't take a lot of time for US producers to lose the market. So in 1980, there were the topic came into being, like, if Japan can, why can't we? This was the topic for US industrialists. Like even Dr. Deming was also talking in these TV shows and radio shows during the time. So they were trying to figure out, if Japan can be successful, why can't we? So one of the things they realized was sharing of best practices within the Japanese culture than US culture. So was one of the things for Japanese people to be successful, Japanese industrialists to be successful. So they started some of the initiatives in the Western world. One of the things is 1987, they started ISO. It didn't really become a very success for Western. They initially thought ISO is going to be the dictator in terms of qualifying suppliers. But it didn't really become so. Because one of the things is it ensures the consistency of the process, but not the quality of the product, was one of the drawbacks ISO had. Another initiative was starting of the Malcolm Baldrige Award in 1987. This award the objective of this award was the winner of this award would have to come forward and share how they became so successful. So to share the best practices was the idea. So from this award, the first winner in 1987 was Motorola. Here also in Sri Lanka also, this award scheme is going on by the name of National Quality Award, done by SLSI. The same criteria, updated criteria, is being used as in Malcolm Baldrige. So Motorola became the winner. So they had to come forward and share their story. So they were sharing their success project called Bandit Project. This Bandit project was focusing about their electronic devices during the time, how it was competing with the Japanese competitor NEC. So this project methodology they followed had a certain style called MAIC, M-A-I-C. That means the measure, analyze, improve, and control. These 4 stages were there in this project. So this became industrial practice. I mean, a best practice for other people to also adopt this methodology as MAIC methodology. But thereafter, some of the industrialists like IBM Consulting, they they improved this methodology, adding a defined stage in front of this. So it becomes DMAKE methodology: define, measure, analyze, improve, and control. So this became popular within a lot of American industrialists. In mid 90s, Elite Signal, their MD CEO Ali Busadi, he adapted this methodology and became very successful. And then one of his very good friends was Jack Welch. During this time, Jack Welch was not very popular, but he was also he was the CEO of General Electric. He adopted this DMAKE methodology with influence from his friend Ali Busadi, and then it became very successful within General Electric because Jack Welch, he documented all the success stories and shared within the industry. That became many of the people to use Six Sigma. So if we ask Jack Welch, what do we mean by Six Sigma? What is it that we call Six Sigma? He says it's a quality program, when all said and done, improves your customer experience, lowers your cost, and build better leaders. So aren't these all three: customer experience, lowering cost, and better leaders for tomorrow of the organization? So these are the main pillars in Six Sigma for an organizational embodied. So we'll see what Six Sigma is in my other set of slides. So if you have any, questions or anything you want to share, you can also do so. While I get my other slide deck. So this Jack Welch success in General Electric was very popular. Within 3 years of time, he was they were able to save and make benefits about $5 billion in early 2000s. And they published their savings and their projects and share within the industry. So it became very popular. Six Sigma as a methodology became very popular thanks to Jack Welch for that reason. So what is Six Sigma? So you would have probably heard about Six Sigma. Some of you would already know about Six Sigma. So what have you heard about Six Sigma? What do you know about Six Sigma? Maybe what do you think it is? You can be correct or wrong, but you can share your point of view. What is Six Sigma in your point of view? Anyone want to take a chance? All right, let me continue. So the main thing in Six Sigma is not being afraid to make a mistake, because we learn through mistakes. So during even our Six Sigma trainings, what we say is come forward and share your things. Don't be afraid to make a mistake, because it's a learning atmosphere, and don't be afraid to make a mistake. If I take Six Sigma as a terminology, of course, any of you know about statistics would call it, yes, it's a statistical term of variation. Yes, Six Sigma level of quality indicates 3.4 defects per million opportunities, which is almost near perfection. But there are certain industries they have to go beyond Six Sigma level of quality. I'll briefly touch upon that as well. So roughly saying, Six Sigma is about improving the variations. It's more than a methodology, it's a culture. Embedding this culture in an organization. variation, say for instance, now this is the behavior, general behavior data set of a call center. Time taken to say you are calling the bank hotline, the time taken to pick the phone by the call center is this behavior. But the customer has a critical customer requirement. The call has to be picked up within, say, 10 seconds or 15 seconds. It has to be answered. So this is the customer requirement. So whatever the calls go beyond 15 seconds to answer are defects. Before 15 second answered are the quality output. So when this is the natural behavior of that, so obviously there's a defect region. By reducing the variation, we can improve that behavior up to this level. That is one way of improving this quality, or we can move this mean curve towards this way and improve the quality as well. So working with this variation is what we do in Six Sigma. If I come to more known example, say if this is golf. So in golf, if you are at 2 sigma level, if you miss 6 puts in per round, see there are 18 puts per round. So 1/3 of them is lost. You miss, and so that's 2 sigma level. But if you improve your sigma level, you get more accurate. At 6 sigma level, you would miss only 1 put every 163 years if you do 100 rounds of goals per year. But even this quality level is not sufficient for certain industries. The reason is, if I take the aviation industry, I mean before the pandemic, there were about 1 million commercial flight landings and taking offs happening all over the world. So 1 million landings of commercial flights happen a week. So at 3.4 defects per million opportunities, that means at 6 sigma quality level of landings, 3 or 4 landings can go wrong. Is that acceptable at any level for us? I don't think so. We are not acceptable having 3 or 4 crash landings. So obviously these industries such as aviation has to go beyond 6 sigma quality levels. So what makes Caterpillar starts on 6 sigma was back in 2001 when Chairman CEO Glenn Barton was the person who started 6 sigma at Caterpillar. The reason was actually at Caterpillar there was a huge, I mean, increased target we had to achieve in 2005. We had to achieve a 30 billion revenue. So Glenn Barton started this initiative in 2001. So at the end of 2004, we were able to reach 1 year in advance. We were able to achieve the 30 billion target. I think 33 billion revenue we achieved in 2004, 1 year in advance. Apart from that, there were a lot of savings, about 1 billion savings all over. So making quantum leaps in quality and reliability in the products and services was the success at Caterpillar. I don't think many of you know Caterpillar is the organization who deployed 6 sigma in a global platform for the first time. We don't highly talk about it. We take it very humbly. We are proud about that achievement. I will show you some of the data relevant to that implementation also. The simple secret was the committed leadership, because the success of 6 sigma we identified in the beginning. There are certain critical success factors. centered around committed leadership. Because of Glenn Barton's his committed leadership, starting the Six Sigma launch in 15th January 2001, there were within the year, I mean within couple of months, by the end of September, almost 0.1% of entire staff of Caterpillar is certified in Six Sigma as certified as Six Sigma professionals, and in various capacities. We ran a couple of training rounds globally during the year in 2001, starting the initiative. Playing different roles, there were black belts, master black belts, green belts, process owners, so many other people involved in this process in the Six Sigma organization, obtaining those trainings to play their roles. Having these roles and having this deployment is fine, but what makes it successful was having the right projects. So what kind of projects are we doing in Six Sigma? So if we look at the type of projects, here's could it be process weaknesses? The process weakness could be a transactional process or a manufacturing process, could be the process of increasing the market share, or increasing the profitability, or maybe improving a cycle time in production line, or cycle time in a service environment. So any kind of these projects could be a project idea, but there's a methodology that we follow in prioritizing and filtering projects. For it to be successful, any Six Sigma project to start, that particular problem should be a problem that we do not know the answer. Because if we know the answer, we don't have to do a Six Sigma project, we can simply implement the solution. For instance, if when you are sick, you go to the doctor to get the medicine, so the doctor would do the diagnosis and give you the medicine. But if you know or already know what is the problem, you can just take a medicine, some simple home medicine, and take the treatment. So diagnosing is a major part in Six Sigma. If diagnosing is not required, there is no point of using the resources, the manpower resources and other resources to run a Six Sigma project. Of course, the process improvement or development and the bottom line impact is something we really monitor in these projects. Yes, the project idea generation and then the project filter. We run the project filter on an annual basis. I will roughly show you some of the criteria we use in prioritizing the project. Of course, the dollar return, alignment to critical success factors and strategic areas of improvement of the organization. And an organization can have an annual focus in certain areas. 1 year, I mean, could be focusing on one particular product line, or maybe trying to improve the staff satisfaction. So for given 1 year, there can be several focus areas. So strategic areas of improvement could be different. Also, the data has to be there. It's highly data-driven projects. Knowledge of root cause and solutions. So the subject matter experts have to be there. Apart from that, the timelines and the current focus on the processes, the current and future processes have to be there. So, of course, if the solution is not already known, we wouldn't go to start a Six Sigma project. What we say is, go ahead and implement the solution. Why waste time or Six Sigma resources in doing a Six Sigma project? And also, even if the solution is not known, the data availability. If the data is not available, we might not start a Six Sigma project, but we will simply start collecting the data. If the root cause is also known, then implement the solution. You don't have to do a Six Sigma project. Also, if somebody else is working on that particular problem, then let them do that, focus on that problem, and your team can focus on some other Six Sigma project. Apart from these areas, the strategic areas of improvement and the critical success factors of an organization also have to be considered, and the dollar threshold limits. So there has to be a threshold limit based on the organizations. We identify these limits in starting the projects. Does it improve an existing process? So I will share in the coming slides. There are two types of projects. The methodologies being used in Six Sigma projects. One is DMAD projects. Other one is DMake projects. The Motorola introduced process. The methodology is the DMAD, not DMake. Sorry, is the DMake methodology. Is the starting of Six Sigma. The most commonly used methodology is DMake. DMAD projects are also done for new product introductions, new areas, and the scope. If the project can't be completed within 6 months of time, we have to revisit the scope of the project. Maybe multiple projects are required to run the project, because if it can't be completed within 6 months, that means the project can become obsolete when at the completion time. So when we identify these projects, then what's next? Then we charter the project. We develop a project charter. We call this project charter six-pack project charter. Because it has 6 elements. We all know what we mean by 6 packs, of course. So maybe going with that same terminology, we call this a 6-pack project charter. Most interestingly, the project description has to be in one slide. It has to be concisely presented to the leadership. One of the interesting things I found in Six Sigma is that there are no reports written or the big documents written, research details written in Six Sigma projects. All the reporting happens through PowerPoint. Because when it comes to executive reporting, executives might not dig into the detailed document reports, but a concisely presented presentation is the way to go. So because of that, so the project also has to be presented in a 6-pack project charter in one slide. The business case, why should we do the project? What is the benefit for the organization by doing the project? And the opportunity statement. What kind of pain of the customer, what kind of pain of the staff and the organization can be given solutions by running the project. And of course, the goal statement. As we all know, the goal statement has to be SMART. And the scope, project scope. What are the areas we are going to be focusing, and what are the areas we are going to not be focusing? The scope clearly has to be defined. The project plan and the team. So we call these the project charter as a living document. Throughout the lifetime of the project, this project charter can have changes. There can be changes to project scope. When the project scope changes, there can be new team members appointed. So when that happens, the timeline can, when scope is reduced, the timeline also would reduce. The targets could also be changed. So we call this as a living document, but those changes have to be approved by the leadership team of that organization. So this is an example of a project charter. But we will come back to this if time permits to discuss in detail. So this DMake process, the methodology is rather used to improve a process, because whenever there's a product or service, there is a process, and this process would produce this product or even the service. And when there is a process, of course, there will be a performance variation of this process. So this performance variation or this creating waste will make an opportunity for performance with improvement. This opportunity will give the hype to need to do Six Sigma projects. Yes, as I said, yes, DMAD projects and DMake projects are there. DMAD projects are done for creation process. I mean, totally new product being introduced or totally new service being introduced. Then DMAD projects are done. This scope is quite high, like designing a new product from the scratch. Usually people who specialize and become expert in DMake methodology would go to become expert in DMAD methodology. So most of the projects that we run are DMake projects in today's context. Yes, this methodology was initiated by Motorola, and then the industrial bodies who added adding D, the defined stage. And then, of course, the process management side of it, using the PDCA cycle. Most of us know about the PDCA cycle. I'm not going to touch about this area. So a DMAD process will have defining stage, measure stage. We collect the customer requirements, customer VOC, voice of customer, using models like the Kano model, and then explore design concepts. Thereafter, evaluating the detailed concepts and selecting what is the optimum design relevant or most appropriate for the project, and implementing it. So this is the DMAD methodology, but mostly what we use is the DMake methodology. Define opportunities, measure performance, define as is and to be process, the future state and the current state of a process, and then measure by the means of KPIs. There are input KPIs, process KPIs, and output KPIs. Based on these measurements, we identify what has to be measured, and then we analyze what the data gathered through measurement space, and using that we identify the root cause or the problem statement, and find the solutions in the improved stage. And then to sustain the benefits, we go on to the control stage. So in this DMake cycle, define, measure, analyze, improve, and control, what really happens is we start with a business problem, and then we convert that business problem to an analytical or statistical problem. And then we use a lot of statistical tools to solve that problem, to come to a statistical solution, and then we represent it in a business solution, mainly using the measurements and using the statistical tools. We identify the problem statement at the end of the analysis stage. This becomes actually very key output at the end of the analysis stage, because we need to know what is the problem to find the solutions. Like a doctor is identifying what is the root cause of the sickness. The complete diagnosis happens at the end of the analysis stage, and then go to the solutions. Like Einstein said, if I had an hour to solve a problem, I spend 55 minutes thinking about the problem, and then 5 minutes thinking about the solutions. So this is at the end of the analysis stage, the importance of identifying the root causes, the problem statement. Identifying the problem statement comes into light with this view. Of course, there are lots of statistical models being used. I'm not going to touch in detail in these areas. Apart from the DMake process or DMake projects, there are VST projects. You might have heard about value stream transformation projects, which has 4 stages: pre-work, find it, fix it, and sustain it. But these projects also progress in line with the DMake methodology. Mainly in the pre-work stage, it focuses on the define and the measure areas. Find it at the end of the find it stage, it will identify what is the problem, the root cause. The measure and analysis tools would be used at the find it stage. Similarly, at the end, we'll sustain the project benefits using the control tools. Apart from the VST projects, we also do have the RIW process, which is the high phase project for very small scopes, like 9 weeks rigorous approach to complete and sign off the project entirely on only 9 weeks is used in RIW. Even could be much lesser than that based on the scope. All and all these the continuous improvement projects focuses on 3 areas within Caterpillar. We take it as the cultural system, the management system, and the operating system. So all of these 3 has to go hand in hand, because once we implement the solutions, the new way of doing things, it has to be the usual day at work. Like it has to be the culture. So in these 3 areas, there are other focus areas in operating system, cultural system, and the management system. Some of you would have heard about these tools we use in these systems, but mainly we focus in adhering to DMake methodology, the DMake principle in running the projects. And these are also some of the tools being used, and the 8 wastes. Many lean initiatives, and even before myself, I got into work with Caterpillar. I had learned about 7 wastes. When I come to work for Caterpillar, I learned about 8 wastes. There was additional 1 waste. In this picture now, there are 8 wastes given. And when I come to Caterpillar, I come to learn that additional waste that they introduce is the most important one. What they call as the most important one is the unused creativity, that additional waste. These other 7 wastes are very commonly spoken about in the lean teachings. But why Caterpillar or CPS, Caterpillar Production System, says this one is the most important one? Because this is the one is relevant to identifying all these wastes and taking action or fighting against these wastes, having the motive to do that, initiate action against these wastes, all is part of this. And also it's not very important to categorize the waste into these buckets. What is important about these categories is it allows us to think in different angles to identify different types of waste. So our mind is opened up to at least look into these 8 areas. It doesn't really matter when we identify waste which category it belongs to, but initiating action to fight against the waste is the important thing. So then the leadership reviews, because when we identify projects, when we know what to fight against, there has to be governance framework to make sure it runs in the right directions. So there are 2 types of leadership reviews taking place within Caterpillar. One is weekly project reviews with the project sponsor who will initiate the project, who has the problem. There should be weekly project reviews with the sponsor, and then monthly formal project reviews with the leadership team. For each stage completion, now when we say DMake projects, there are 5 phases involved: define, measure, analyze, improve, and control. At the end of each of these phases in the project, there needs to have a formal project review with the leadership team. In these leadership reviews, we present the storyboards. These storyboards are not written documents, as I said, are the PowerPoints. Pictorially or graphically explain how the story went ahead in identifying the root causes of the problem and then identifying the solutions and the optimum solution out of those solutions. So this story, as a story, we have to present to the leadership team. Apart from this, the success of Six Sigma worldwide is accounts to its measuring of its the financial impacts of its projects, financial benefits of the projects. There are type of financial benefits that we monitor: level 1 benefits, level 2 and level 3 benefits based on the direct relevance to the project solutions. These level 1, 2 and 3 benefits are identified. For example, now the level 3 benefits are the least relevant to the project. It has only 70% of confidence. So these are not direct benefits from the project, but indirect benefits from the project. So these benefits are monitored up to certain time, depending on the project nature. Usually, a bigger project can take even 18 months of time. So this particular time period is taken to complete a project. And thereafter, there is a benefit realization cycle, sometime allowed for the benefits comes. We also call this as the delta period. I will roughly touch on that if time permits. And then the annualized benefits for certification for green belts, black belts. For their certifications, the project benefits have to be shown. For that, after 2 months, we take the benefits and annualize for their certifications. And then after 6 months, for incentives, we take the annualized benefits, and the project benefits is realized at the end of 12 months. So the change management is a very important part in Six Sigma projects, because we improve or we introduce new way of doing things. So this is definitely a change to an existing frame of work. Of course, it is said only a person likes a change is a wet baby, but you all also, as people who are working with projects, we know there are 3 reasons that they say project fail. No plan for implementation, fussy definition of desired stage, and ignorance of resistance. So when it comes to working with the resistance, the change management is a definite requirement. For these 3 areas, of course, the Lean Six Sigma tools and the methodology, the DMAIC methodology, will define what the change is. Of course, the business risk management will identify the risks and assess and manage the risks from that. Of course, the change management resistance is also one of the risks coming from belonging to this area as well. That particular resistance is taken as a separate area to give high prominence to that area. We use in CPS, in Caterpillar Production System, we use the CGCM model in dealing with resistance or the change management in these 3 stages: current stage, desired stage, and the delta stage. The delta stage, yes, would ask how the change should happen from going to desired stage from the current stage, because desired stage is the optimum stage that as a solution the project people have found. The current stage is the way that we are operating, that we are thinking is the best way right now. So interim period, there would be a lot of turbulence and a lot of changes going on in multiple areas, is the delta stage. So will not have the characteristics of the current stage and the desired stage. So it's a turbulent time that we call as the delta stage. In using the CGCM model, the 5 steps, Caterpillar Global Change Management Model, we deal with the change management. There are specific tools we use in that as well, especially when we implement change. The cultural change has to be there to sustain the benefits for the future to come, because it has to be the normal day at work when the new things also come to the picture. Because of that, the culture is very important. Especially we give high prominence to that area. Culture is how we act, we believe, and rules that we follow. So we need to identify what are the unwanted behaviors, unwanted beliefs, and unwanted rules in the current picture, and then what are the desired things. Apart from that, what are the new things should come into the system. So through delta stage, from the current stage, we get there using the CGCM model. This is the way we make the cultural transformation in Six Sigma. Organization starts with piloting Six Sigma methodology, and then they go with some leadership compliance, or because the leadership say, they start just complying with it to deploy Six Sigma. But when they see the benefits, they start committing to the Six Sigma methodology and adapting to it. With that, the integration would happen in an organization to Six Sigma methodology. That culture, automatically it becomes embedded to the DNA of an organization, becoming an encoded Six Sigma organization. So it's a matter of time how you manage through the process this delta stage until you come to an encoded Six Sigma organization. Of course, this change is not linear. There are going back and forth, falling back again and going up back again. So it's not a linear process. It is commonly said within Caterpillar, transformational change can be a little bit like herding cats. Some of you would have heard about the sound of the noise of herding cats. So that's actually concludes the session. So I will open the forum for questions, and if you have any questions to ask, also do share your feedback. There's an evaluation form in this QR code. I would really appreciate your feedback about this session to improve this session for future events.